take a look at these definitions, and postulates, and theorems that we have for angles, right? So the first few, we just have, 6 definitions, and these are all things that we've actually already talked about, right? Definition of congruence, we talked about this idea for segments. We're also going to use it for angles, right? The biggest thing here is just the notation. If I'm talking about the measures of angles, that's where we have to put those lowercase m's out in front. Okay, so we can say measures of angles are equal, just like we said lengths of segments are equal. And then the actual geometric figures of angles are congruent to each other. Just like we said, the geometric figure of a segment, or segments are congruent to each other. Okay, we also talked about bisectors. Okay, an angle bisector, we just know cuts an angle into 2 equal parts. Okay, so if we're told that something is an angle bisector, we'll be able to say that the measures of 2 angles are equal. Definition of complementary just means we can say 2 angles add to 90. Right? So I guess I should write, we'll be able to set up equations here. Right? We'll be able to say that 2 angles are equal to each other if we know that we have an angle bisector. Right? If we have complementary angles, what we'll be able to say is 2 angles, their measures add to 90. If we know 2 angles are supplementary, we'll be able to set up an equation. Say the measures of those 2 angles will add to 180. Definition of perpendicular, here we know what that is as well. Perpendicular lines form right angles. And then definition of a right angle, and we can say that we know something's a right angle, that measure equals 90 degrees. We talked about the segment addition postulate, right? Adding 2 pieces of a segment would equal the whole. We're going to use that same idea for angles as well here. Okay, so in this example, I can say that the measure of angle ABD plus the equals the measure of the whole thing, ABC. Okay, same idea as what we did for segments. Okay. Then on the bottom, we have some theorems. Still see much writing. Maybe another second. All right. Theorems then are actually things that can be proven. Right? We said we take postulates as something that are just true. Right, so we've got 5 theorems down here on the bottom. We've talked about a couple of these already. Okay? We know what vertical angles are. Right? If we're told that, or even in the diagram, we can see that 2 things are vertical angles. They're congruent. Right? So if I know that 2 angles are vertical angles, right, I can state that they're congruent to each other. And we could be told that, or we could just recognize that in a diagram. Complement theorem. Okay? If we can see in a diagram that 2 angles form a right angle, so angle 1 and angle 2, and if I can see that they form a right angle together, I can say that they're complementary. Supplement theorem, same idea. If I can see that 2 angles form a linear pair, right, so angles 1 and 2 here, then I can say they are supplementary. These last 2 are the 2 that maybe aren't as common sense. Okay? I think most of the rest of these we've either looked at before or are fairly, fairly common sense, right? If we can see 2 angles form a right angle, then they're complementary. We can see they form a straight line together, supplementary. Those ones are kind of common sense. The last 2, okay, this one says if angle A is complementary to B and C is complementary to B, so 2 angles complementary to the same angle, then they're congruent to each other. Okay, well, what's happening here is if we say, let's say we've got angles A and B here, and they are complementary to each other. Well, then I add a third angle on there, angle C, and I say that that is also complementary to B. The only way for it to be complementary to B is if these two angles have the same measure. Right? So, for example, if we say that angle B is 30 degrees, angle A would have to be 60, right? Well, if C is also complementary to B, it would also have to be 60 degrees, right? So if two angles are complementary to the same angle, they have to be the same, right? They have to be congruent to each other. Very similar idea for the congruent supplements theorem. Okay? If I have two angles that are supplementary to the same angle, they have to be congruent. Okay? And this one I think is a little bit easier to visualize. Right? So if we say, here's angle A, angle B, and we take some other angle C, okay, and say that that is also supplementary to B. Okay, well, A and B are supplementary. They form a straight line together. Well, then, for C and B to be supplementary, they would also have to form a straight line together. Then A and C are vertical. They would have to be congruent to each other. Okay, we could also just think about that in terms of measurements, like we did here. Right? If we say that A is 120, then B would have to be 60. Well, then for C to be supplementary to B, it would also have to be 120. All right. Any questions on these definitions, postulates, and theorems? All right, so then just like we did for segments, we're going to take a little bit of time here, and on the back, we're going to try to identify which of these things is occurring. Now, remember, okay, we can still use addition, subtraction, multiplication, division, all of those properties for equations that we've already talked about. Okay, we're just adding a few new ones for angles. Okay, so we can still have an equation where we're talking about the measures of angles and add the same measure to both sides of the equation. Okay, so let's take around 10 minutes or so here and try to match up which property we have. Alright, let's take a look at some answers here. Take a look up here.
Use the third one.
Where?
Vertical angle theorem.
That's how you spell theorem.
No, T-H-E-R-M.
Theorem. T-H-E-O-R-E-M.
I spelled it wrong. I'm just like, I swear.
Alright, and then here's the last couple of them. Any questions on any of these? Any that we want to take a closer look at? We get 100% of them correct. Sweet. So now let's take a look at applying these to proofs.
Yeah.
Guess what's your biggest organ in your body?
Oh no.
Alright, let's take a look at a couple of these together here. Let's take a look at a couple of these together. So, on number one, the only thing we're given is that angle PQR is a right angle. Okay, but for angle proofs, we're going to use the diagrams maybe a little bit more than we did for the segment proofs. Okay, so what's my reason for PQR as a right angle? Given, right? First line is always the given information. Well then, how can I say that the measure of angle PQR is 90? Definition of a right angle, right? We know it's a right angle. Definition of a right angle is that the measure is 90. Okay, well now they state that the measure of angle PQS plus the measure of angle SQR equals the measure of angle PQR. How can I say that? Yeah, if we look at the diagram, right, they're just saying this angle plus this angle equals that whole angle. That's the angle addition postulate. Well, then they claimed that the measure of angle PQS and the measure of angle SQR is 90. Well, our goal is to prove that they're complementary. So I don't know that they're complementary yet.
How do you get to that?
It says that PQR is a right angle. That's the only thing we know. So then we want to prove that those two angles are supplementary.
Oh, no. It's
Substitution.
it's substitution.
So if we take a look at these two equations, right, we know that PQR is equal to 90. So all they did was substitute 90 in place of the measure of angle PQR. So substitution. I think we could also have used transitive. Right? Transitive would work in this case, but let's say substitution. So now, if I know these two angles add to 90, how can I claim they're complementary? Definition of complementary. Okay, so remember, we're still going to be using properties like substitution or addition or subtraction. Those are still going to creep up here. So we're dealing with equations. Okay, but we're just introducing some of these new ones for angles. Right? You okay with that one? You guys want to try one, or are we going to do another one together? Alright, let's do another one together. Maybe. There we go. Alright, so on this one, we're given a little bit more information. Alright, so again, there wasn't really anything to mark on the last diagram, but marking things on a diagram is always a good idea. So I'm told angles 2 and 3 are congruent. Remember, to mark angles congruent, or say they have the same measure, we put the same number of arcs in those angles on a diagram. Right, so I can put one arc in each of the angles 2 and 3. So my first line, angles 2 and 3 are congruent, that's given. How then can I claim that the measure of angle 2 is equal to the measure of angle 3? Definition of congruence. Right? If two things are congruent, then their measures are equal. Well then, angles 1 and 2 form a linear pair. That's right, that's our other piece of given information. Well then, how can I claim that angles 1 and 2 are supplementary? I think I heard it. Supplement theorem. And if we know two things are a linear pair, then I can say they're supplementary by the supplement theorem. Well, then they claim that their measures add to 180. How can we do that? Definition of supplementary. Right? If I know two angles are supplementary, then their angle or their measures add to 180 because that's just what supplementary means. Well, now they claim that the measure of angle 1 plus the measure of angle 3 is 180. Substitution, right? We know 2 and 3 are equal, so they just substituted that one in. And then finally, if angles 1 and 3 add to 180, how can I claim that they're supplementary? Definition of supplementary. Feel okay with that one? Ready to try one? Alright, go ahead and try number 3 then.
We're using the last one. What'd you get, Aaron? What? Just the button. Definition of writing. We'll give him definition of writing. For the last.
Go ahead and move on to the next one if you guys finished up number 3 here. Okay, we'll go over a couple of them here in a second.
And he starts cutting it out. I'm like, oh no, I was trying to fix it. Apparently I had to
You'll never beat me, Roger.
I mean, you can. Wait, I don't think it is. I think it's I think it's
It's like it was that birthday. Right.
A little.
Alright, let's go over a couple of these together here.
Okay, that's the definition.
Okay, I've got number 3 up here on the board. Okay, on this one, we are given angles 1 and 2 form a right angle. Okay, well, the definition of a right angle then is that they are, wait a minute, actually, that's not a definition of a right angle, is it?
No.
That's a definition of, no, not complementary, yeah. Sorry. Okay, then we're also given that angles 1 and 3 add to 90. So from that, we can say that angles 1 and 3 are complementary. That's just definition of complementary. Well then, I've got both angles 2 and 3 complementary to the same thing. If 2 angles are both complementary to the same thing, we can automatically say they're congruent by the congruent complements theorem.
Wouldn't that be complementary?
For number 2?
Yes.
Oh yeah, you're right. You're right.
It doesn't use
Oh my goodness. What is the real answer? What's the real answer?
Complement theorem.
I think it's
You guys are doing so good at this together. Give me like
Ooh, wait.